All right. I think we can go ahead and get started. And as more people join in, they can obviously catch up with the webinar as well. So yeah, today the presentation I'm going to be giving is on cloud computing. Just giving an introduction to what cloud computing is, what are some of the ideas behind cloud computing, and what are some of the ways it's used in sort of like the current sort of technological landscape. And as always, if there's any questions you have throughout the presentation, I'll be like intermittently checking the chat as well. You can send in the Q&A. I'll try to leave some time at the end as well to answer questions too. So as always, there's a quick disclaimer saying that we're not complete professionals on this topic. There might be some things wrong in the slides, but we try our best. We make our best effort to make sure we do our research thoroughly and check our work over again to make sure everything's as correct as possible, since it's intended to be used for educational purposes. So what's the sort of agenda for this presentation? What are we going to be talking about? We're going to be talking about a little bit of an overview of cloud computing. What are some of the ways it's actually deployed and used in real life? What are the types of services that it provides? And what are some of the use cases as well? So first of all, what is cloud computing? I mean, sometimes you hear it in the news, sometimes you hear people talk about it. What does this sort of cloud computing idea mean? Cloud computing essentially means letting people access computers and resources on demand via the internet. So right now, let's say you're watching this sort of like presentation, this webinar on your laptop, you're watching on your phone. That's your own sort of device. It's your own laptop, own computer, own desktop, whatever you're watching it on. Cloud computing is essentially saying, how can I access someone else's computer, someone else's laptop? Let's say I want to develop something on an iPad, but I don't have an iPad for myself. How can I access another person's iPad, this company's iPad, and do my work on there without having to own the iPad for myself? That's the same sort of like similar sort of concept. It's essentially accessing another company or another group's resources, or computer resources, or compute their databases, things like that, while not having to, while not physically owning that thing and accessing that via the internet. And these sort of IT resources can be anything from like compute power to storage to databases, applications, anything you can think about. And what it enables you to do is it stops. You don't have to like think about the hardware. You don't have to think about, oh, if I want to make this work, I have to get like 10 computers. I have to get this server to run this. I have to take care of the power, the heating, the cooling, everything like that. It just lets you stop thinking about that infrastructure part as a whole, and instead of think of the infrastructure as software and use it as you see fit. And it's increasing in use. Almost every company nowadays uses cloud computing in some way, shape, or form. And they're usually increasing the amount of cloud computing they're using as well. Because they want to buy away from owning like these on-premises hardware, their data centers, maintaining it. It takes a lot of effort, takes a lot of time. But the cloud offers scalability, flexibility, potentially lower costs, and you don't need to do any infrastructure management as well. So the key sort of terminology here is trading capital for variable expense. Capital expense is essentially just stuff that you pay upfront. Let's say you to buy 10 servers. Let's say your like website needs 10 servers to be handle the load of it. And so you can say, okay, at maximum I'll need 10 servers, but at minimum usually only need one. If you're buying it for yourself, you have to pay all for that 10 servers upfront. But with variable expense, you're able to pay as you go, pay as you need, and you're able to pay for only what you use, which is a lot better for large economies of scale. For larger and larger companies, you only have to pay for as much as you use, not for just getting started. And you don't have to guess this capacity either. Like you don't know how much traffic or how much usage your like website application software is going to get. And you don't have to guess either. You can just pay for as much as it uses. As soon as it gets lower, you can pay less. If it gets more traffic, you can pay more. And it lets you deploy much faster since you don't have to worry about infrastructure at all. And one of the other big things is being able to go globally. If you wanted to deploy an application on the Google Play Store or the App Store, and you wanted to be able to host it, instead of having to worry about, oh, how do I host my application for people in India or people in China or people in South Africa, you can just deploy your app to the cloud and it goes global in minutes, and it's able to be accessed across multiple regions across the entire world. So what are the sort of deployment models to the cloud. By deployment models, you mean like how do people actually use the cloud? How do companies use the cloud? And there's sort of three main ways that people use the cloud. One is private. So this is like, let's say government companies or defense companies. When someone needs to use their own sort of on premises, which means like they're in their own offices, in their own data centers, they need to use their own resources and can't send things over the internet or trust another company. That's what's called on premise. Usually it's like a high level of security, and you need to be able to run everything and host everything yourself. The next thing is hybrid. So let's say you can send maybe 50% of your servers or your data centers in the cloud. That's sort of the hybrid model. It's when you run half or maybe some proportion of your stuff in the cloud, some proportion on premises. And then the public cloud is just it's what's freely available. If you're taking advantage of a company's resources fully, there's no upfront investment to like getting it set up and hosted. AWS or Azure already have their programs up and running. You can focus on your innovation, and you have flexible capacity while being able to focus on your speed. And you don't have to worry about your global reach as well because it's already set up for you. You just have to take advantage of it. So what are some of the things that you hear about when you're dealing with the cloud? So there's a few main categories of this as well. So this is what's the sort of model that the cloud runs on? Like what services does it provide? The first one that you'll see is what's called software as a service. So software as a service is, let's say I make a game or I make some sort of game on my computer, and I want to be able to send that game to the internet. I want to be able to host it online for people to be able to see across the entire globe. In this scenario, you sort of make the application and you're able to host and deliver it via the internet. The next thing is platform as a service. So platform as a service lets you build, run, and manage some new cloud operations. This is what, let's say you want to host a database in the cloud. Let's say you want to be able to host like an operating system, anything like that. Anything that where you manage the application of the data and everything else is managed by the cloud, that's platform as a service. And then let's say you want to go one step further. Let's say you want to set up like big data centers or like a virtual computer. You want to be able to handle most of what goes on with the computer on your own, and then just have the cloud take care of maybe the networking or the storage or the server side of things. In this case, that's infrastructure as a service. You're using the infrastructure that the cloud provides as the service that you want. Everything else you take care of yourself. You take care of the application, the data, the operating system, whether like your machine is running Windows or Linux or Mac OS. Everything you're taking care of that. They just take care of what's the physical machine that you're running it on. So this is sort of a busy slide, but just a general overview is the left is what traditional computing provides. That's just sort of the pros or the typical like pros and cons of traditional computing. And the right is the pros and cons of cloud computing. So when it comes to infrastructure meaning the like building blocks of your applications, the computers, the servers, the electricity, all of that, things like that. Traditional computing is like on premises. In terms of cost, it's like a high initial capital expense, and it's often maintenance and trying to like deploy it globally is a very time intensive and very money intensive process. Versus the cloud, it's managed by providers, managed by companies. There's a low sort of initial cost. You don't have to pay for a lot to get started. You just pay more as you use more. And it's pretty automatic and seamless when it comes to maintaining your applications, sending them across the world. And security is a lot easier to provide as well, because part of it's taken care of by them and part of it's taken care of by yourself. And you only pay for what you use versus paying for a large amount up front. So the advantages, like I mentioned before, are you have these lower upfront costs. If I know that I'm going to make a game and I want to deploy it, maybe the first week I only have like 10 users. I only have to pay for that 10 users, and I get a very low starting cost. If my game gets popular and I get 1,000 or 1,000,000 users, I can just pay more as I make more. And it scales easily like that as well. So you're not ever paying outside of your means. And you can scale resources up and down based on demands and automatically have backups and ensure your data is safe. But the disadvantage is it requires a constant connection to the internet. It's tough to do offline applications on the cloud. and you have less control over like the infrastructure, and maybe you don't want to be locked into using this particular machine or particular like Windows. Um, and it can accumulate costs over time, especially as you sort of have more and more things running on the cloud. That the cost can definitely add up. So who are the big like sort of players in the cloud? You may have heard of some of these before, but some of the big ones are Amazon Web Services, which is AWS. They have the biggest sort of market share at 31%. And then there's Azure and Google Cloud, which are the two next biggest ones, each one holding 25 to 11% of the cloud. And those three are pretty much the big three players of the cloud. Most companies you go to, most people you talk to will know about either AWS, Azure, Google Cloud. And then there's still like big players in the field like Alibaba, Salesforce, IBM, and Oracle and Tencent, which are more sort of, they're more niche for certain use cases. Like Tencent and Alibaba may be used a lot in East Asia. Salesforce might be used a lot among like finance companies, and IBM and Oracle are used a lot by like large scale like IT organizations as well. But it's a very big field. It's a $76 billion industry just in the first few months of 2024, which is crazy. So let's talk a little bit about AWS. So what is AWS? It's the one that I have the most familiarity with, and it's one of the biggest ones as well. So chances are, if you ever do work in the cloud or hear about the cloud, you'll be hearing about AWS. So AWS stands for Amazon Web Services. What are web services, you might be asking? I'm sure you know what Amazon is. A web service is just any piece of software that makes itself available over the internet. This like webinar you're watching right now is a web service. It's a software, it's this whole webinar thing. I'm able to host it, you're able to view it, that's a web service. And it uses a standardized format for the request and the response of an interaction. So let's say you make a request, say, I want to be able to view this webinar. It'll send you a response back with the webinar viewing and the whole recording and everything like that. And that's what it puts that into a standardized format. And it has hundreds of different services that are provided within it as well. So what are the sort of facets of the cloud? These are the things that we're going to be talking about. And these are the things that's common among all three big cloud providers, Azure, AWS, Google Cloud, all have these main components: region availability zones, storage, compute, databases, networking, market share, and major clients. I'll be breaking down a comparison between the three big the three big companies that work in the cloud. I'll be breaking down each one of these components in relation to what they work on. So first one, what's the origin of these three companies? So AWS was launched first out of the three big cloud providers, and they just launched with this one thing they have called Simple Queue Service, which is something that lets you put messages to a queue and something else can take them out. And it was introduced in 2006, and it started off with the SQS, and then they immediately after built their storage and their compute services. Then in 2008, Google Cloud launched their App Engine, which offered web hosting on Google's infrastructure. As you know, Google has a large infrastructure of hosting things on the web, and then officially launched in 2011. And then Azure was launched in 2010, initially named Windows Azure, but then Microsoft made a big push for their branding to move everything towards Microsoft. So now they became Microsoft Azure in 2014. Regions and availability zones. So what are regions and availability zones? These are also the terms you're going to hear a lot about when you're dealing with cloud computing. But a region is a distinct area that houses multiple data centers used for cloud services. So the large way you can think about it is, think about like countries or large scale like geographic borders. So some regions, for example, could be the northeast of the US, the central US, like the United Kingdom, Eastern Europe, South Africa, East Asia, Australia. These sort of sometimes countries, sometimes just large geographic borders, just geographically distinct areas are called regions. So regions sort of help ensure compliance with rules of certain governments or rules of certain regions. That's typically how they're broken up. Like the EU, the European Union, has certain laws, so there's certain regions within the EU. There's also certain regions in the US for certain laws there as well. Now, other countries or other different geographic areas, like maybe the Middle East as a whole, have different requirements with data compliancy. So they just have different regions there as well. And they matter because if you choose the right region, you can improve performance in that region as well. If you know your application is only going to be used by people in New York, then you might as well make your region in northeast of the US, you have the closest proximity to New York. And sometimes the company you're working for, if it's a government company, for example, the US government wouldn't want to host something in China, so they would host it in the US region. Similarly, the cost is also vary slightly between regions as well, depending on the availability of stuff. Next, availability zones. So within each one of these regions, there are multiple availability zones. So let's say US East is a large region. The availability zones are the different data centers within that region. So let's say in the Northeast, there's 4 buildings. One maybe in Virginia, one in New York, one in New Jersey. I don't know exactly where they are, but let's just say there's 4 distinct data centers within the US, like the US Northeast. Each one of those data centers is what's called an availability zone. They have independent power, independent cooling, independent networking, just to make sure that, let's say the Virginia data center goes down, the region of the US East can still be intact because there's still the New York's included in the US East, maybe New Jersey's included in the US East, and there's data centers there that are still running. Typically, regions have around 3 or more availability zones to take care and ensure redundancy. Yeah, deploying things across multiple availability zones can help make sure if your application, let's say a hurricane hits Virginia, your application will still be fine because it'll be replicated in, let's say, New York or New Jersey, for example. So AWS has around 33 regions and 105 availability zones. Azure has around 69 regions, typically and around 200 plus availability zones. And Google Cloud has 38 regions with 115 availability zones. So you might notice that like AWS is a small switch across the globe, but they've placed their regions strategically so that they're in very high impact areas. So that's why they still have a large market share despite having such a small number of regions and availability zones when compared to Azure, Google Cloud as well. Storage. Make sure I have any comments. Cool. So how do you store things in the cloud? Let's say by storage, I mean, let's say you download a document from the internet. It's stored on a file system on your computer, whether it's a Mac or a Windows computer. It's stored somewhere on your computer. It's like a file storage. Let's say you want to store like a database or something, like all the employees in your company. That's like a database storage. We're just going to talk about like generically, what is storage and compute on the cloud? So originally AWS started off with just S3 and EC2, which is how you use S3 is like file storage, and EC2 is like computers that you can access from the cloud. Then they moved on to grow and grow and grow, and each year they come up with new and new features in both the storage compute and in general as well. So what types of storage does AWS have? The first one is called EFS, Elastic File System. And what that is a fully managed like network NFS like file system. What an NFS is it's a network file system. Essentially, it lets you access folders that are shared across the internet. So imagine that your computer has like whatever documents, desktop, pictures, like directories on your like laptop or phone or things like that. And imagine that the documents and desktop and folders that you had were shared across 10 other computers who are on the same network. Let's say everyone in your house shared the same file system, the same desktop folder, the same documents folder, things like that. That's what a network file system is. Next, you have EBS, Elastic Block Store, and that stores like databases, your OS, applications and stuff like that. That's all hosted on block storage. And then you have S3, which is simple storage service. It's highly scalable, highly available. You can serve files over the internet, but it essentially just hosts like individual files and static things. Like if you want to upload an image, you'd upload to S3. Upload a document, you upload to S3. Things that don't need to be like shared and like constantly read and written to, just file storage in general, that's done via S3. And every single one of the cloud providers has pretty much the same, like almost the same services. They're just named different things and have different like small quirks and features as well. So S3 is called blob storage and cloud storage. EBS is called managed disk and persistent disk. EFS is called files and file store. Everything has like individual sort of naming according to the cloud provider you use. So yeah, like I mentioned before, S3 is the object storage. It's called S3 by AWS, then blob storage and cloud storage. And what S3 provides is it provides the ability to like unlimited storage as much as you can pay for, obviously. It's secure, it's scalable, like you can have hundreds of thousands of people accessing your files and the files won't go down. It's durable, like if you upload a file, you can be sure that that file will never be deleted, it'll never be changed, it'll be like corrupted. It's easy to use, it's highly available, you can put your file on the cloud and someone from China could access it just as well as someone from South Africa and the US. And it's low cost. It's pretty low cost depending on how much you store, and it's a lower cost compared to some of the other cloud providers as well. And the way that it'll generally, like these file storages typically work when you're dealing with the cloud is they have what's called buckets. And the buckets are then like containers, or like you can consider them like folders for objects stored in S3. You can store like documents, pictures, etc., whatever you want in it. And you serve those buckets to the internet, and people can upload and download from those buckets as well on the cloud, depending on who you allow access to. And it's useful because you can do disaster recovery with it, like storing backups. You can like archive files, you can just store generic files you want to as well, and you can also host static websites on it, like as well. And within AWS as well, within like storing and S3 storage, there's different ways to storage this, because you might not always want the same type of storage, want to pay for the same type of storage when you're dealing with files. There's like the standard version, which is like, I just want to upload an image and have it there, and want to be able to upload as many images as I want. Next is like infrequent access. Let's say you know you're not going to access this file a lot. You're just like backing up, let's say old like baby photos or something like that. You're not gonna frequently access data. You just want it to be available when you need it. That's what infrequently access is for. It costs a lot less, but it also takes a lot longer for the files to load as well. So it's useful to long retain data. And they have what's called Glacier, which the name sort of gives it away, but it's very, very long-term archives. Let's say you're like a museum and you want to store like documents from like 2,000 years ago. You know, like that now a lot of people are going to want to access it. We want to be able to store all of that information somewhere that's not like just on premises. That's what you use something like Glacier for. And the cool thing about S3 buckets or S3 and like file storage as well is you can replicate the information across like countries, across different regions. You can upload a file here, and you're in New York, you can upload it to the US East, and that same file will be replicated to a bucket in like Asia as well. And that'll allow people in that region to access it with very low latency, while people in New York are also accessing it with very low latency. You can also change the data that you access as well. So obviously, if you want to store something for 30 days in normal, and then after a certain time, move it to infrequently accessed in Glacier as well, you can also set up life cycles like that as well. And as you can see from the cost, each sort of tier that you go down is a fraction of the cost that it takes. So standard S3 takes around 0.023 cents per gigabyte, and then it's half that for the infrequently accessed one, and then a third of that for Glacier storage. So the price for Glacier storage is extremely cheap, but it's also very slow to access files and information. Some of the people that actually use S3 in real life are Netflix. A lot of the like thumbnails and content that you see are actually delivered via S3 on Netflix. Airbnb handles petabytes of images from S3. So those images you see when you're looking at Airbnb listings are all stored in S3. Images from like text messages with your host are also stored in S3. Grubhub uses S3 as well. You know, when you're ordering food, you get a picture of like, hey, your food's been delivered. That's also stored in S3. And NASDAQ as well uses S3 to store years of historical stock market data down to the millisecond for people to access. So here's sort of comparison of how like S3 works across different clouds. All of them are around the same. They all provide a very, very large amount of storage, virtually unlimited. They have crazy durability down to like 12 nines, 99.9999%. They all provide APIs, they all have pricing based on usage, and they all have different use cases as well. It's just up to what cloud provider you're generally using. Next up is sort of block storage. Block storage is just like temporary storage for your compute uses, compute instances, like your computers and stuff like that. Let's say you want to have your computers to have like applications hosted on them or databases, or you want to store the OS for your computer. That's what EBS would be used for. It's just raw storage. You don't need like any file system. You don't need like a C drive or a D drive or anything like that. And you mount them directly to your computer, your compute instances, your EC2 instances. And the benefits are that they're quickly accessible. It's long-term available as well, and they're best suited for these sort of database or application or file system sort of low-level use cases, rather than S3, which is used to like upload files and have access to them whenever you want. So EBS, like the block storage, is different types as well. These are generally types of storage, like when you're like dealing with a computer as well. You've heard of like SSDs or HDDs, solid state drives, and hard disk drives. Nowadays, most modern computers use what's called SSDs, solid state drives, because they're very, very fast. It's the reason why your computer can boot up so fast, why websites can load so fast. It's why games can load fast as well. And HDDs, which are hard disk drives. They're a bit older of a technology, but they're cheaper. And while they do read a little bit slower, they have the same sort of availability and persistency that you want. So SSDs are typically used for most use cases, like most use cases, databases and stuff like that as well, where you have a lot of reads and writes going in and out. You want to have an SSD that can do it fast. But obviously, if you're storing a lot of data, then you can't afford to use all of it in SSDs, so there just wouldn't be enough space to store all that in SSDs. So you use HDDs as well, which can, the size of them can be much larger. You can have like 20 terabytes in one drive. And also, if you don't need to access your data that often, you can use HDDs as well. So like I mentioned before, the use cases are stuff like databases, operating systems, like large like enterprise applications, and anything that you want to just minimize your data recovery and data loss. Like always, the things between clouds are pretty much the same. It's just which cloud provider do you like want to use more, or which cloud provider are you using right now. And especially with EBS or like block storage, there's a lot of differences between the hardware between different companies and consumers as well. So these are two different types of storage, but they have entirely different use cases. EBS is block storage that is very fast, and it's mainly used attached to like a computer instance that you also have running. While S3 is not really attached to a computer instance. It's just if you want to be able to upload documents, images, files like that, and have access to them, that's what S3 is used for. And then we also have what's called like instant store, which are also called ephemeral volumes. These are temporary sort of like elastic block storages that are just attached to your computer. Like let's say you boot up like a computer on the cloud. It only lasts for as long as the computer lasts. It automatically deletes when your computer stops, fails, or is terminated. So it's very temporary. And it's not like snapshot or backed up or anything like that. It's just used for any temporary files you want to store on your computer. When it boots up and when deleted, when it runs, when it is deleted, that's what you can use ephemeral volumes for. And these are also available on all three clouds as well. They're attached to instances of your virtual machines. They're lost on stopping them. And they have different sort of storage and caching requirements across different cloud providers. And the last one is file storage. File storage is what the sort of network files that I was talking about. So a network file storage, like I mentioned before, it's essentially when you have computers that are accessing the same files over the internet. So let's say everyone in your house, all the computers, phones, laptops, tablets in your house, shared a single like a single like folder for all your documents and everything. Anytime you downloaded something from the internet, it would download to that shared storage, and anything that you download from the internet, your sister or your mom will be able to download that, get that same file as well, as if it was on their own computer. That's what a network file system is. And Elastic File System is Amazon's version of that. It can support access from a bunch of different compute instances. It can scale automatically without disruption. And the benefits are is that it simplifies your storage management by having just one file system. You only have to pay for as much as you use. It's encrypted and integrates well with other AWS services with minimal startup and setup costs and being very highly available. And of course, it's available across all the different cloud providers as well. It's called Files on Azure and File Store on Google Cloud. Next is compute. So by compute, like I mentioned originally, compute just means having access to computers on the cloud. So these computers give you the access to having rapid deployment. You have complete control over the computers themselves, like what operating system you want to run on, what files you want on there, what things you want hosted. And they're easy to integrate and they're reliable as well. Like you know that that computer is going to be booted up, it's going to stay booted up for as long as you want it to. And it lets you launch and manage these Unix and Windows server instances on Amazon data centers. And it's similar to what a virtual machine is. A virtual machine being like a computer that doesn't, like you can't physically have access to the computer the same way you have the tablet or the phone you're working on right now, but you can still access and do work on it in a similar way. So it's just shared across like different people. You can run as many or as few of these instances as you want. With across a variety of operating systems. It lets you scale up and down as you need. You can deploy computers across the world. And they have many different purchasing options to make it as cheap as you need it to be or as powerful as you need it to be. And as always, it's highly available, durable, encrypted, minimum fees and startup costs. It's very sort of good for people who just want to get started and for enterprise companies who need a lot of power. And when we mention scaling, like these computers have, or these compute instances called EC2 and AWS have different sort of tiers of scaling. It can be scaled by schedule. Like let's say you're like a shopping company. Let's say you're like Amazon or something like that, or Macy's or Target or anything like GameStop, Best Buy, and you know that you have a Black Friday deal coming up. What you can do is that you can actually schedule your computers to scale to 2 to 5 to 10 times the power that they have, or 10 times the number of computers that you have when it comes time for Black Friday to happen. So if you know that there's going to be a large increase in sales, a large increase in usage at a certain time, you can scale up your computers to be able to handle that large amount of load, and then immediately scale them down afterwards once Black Friday ends. You can scale up, which means like double the amount of computers that you have, or you can scale down as well. So there's like both options available. And you can also scale them by hand as well, if like you want to manually do it. It's not so automatic, but it's still better than having no scalability at all. And there's also scalability available by the way that you buy these compute instances, purchase an EC2. You have like on-demand instances, which just let you spin it up whenever you want, and it takes as much power as it needs to when it to complete the job that you send it to do, and then just turns off whenever you don't need it. And you have reserve instances, which you can buy on a very, very high discount. And they're always going to be available. You reserve that instance specifically for yourself. You don't use it on demand or anything like that. It's always going to be there available for you. There's scheduled instances, which you can schedule for certain time periods. You can have them on a recurring schedule as well. Spot instances, which are pretty interesting. Let's say you have like a random like script you want to run. You don't care when it runs. You just want to be able to run at some time for as cheap as possible. These spot instances, what they do is let's say someone's computer is like on demand and it stops running, it stops running for like an hour to like at like 2 a.m. And you say, okay, I want to bid on whatever the cheapest instance is available, just run my code on it. I don't care if it crashes, just let something run. That's what the spot instances are for. They can run as long as they're available. You can bid on how much money you're willing to spend, and it can often be much cheaper than using like scheduled or reserved instances as well. Dedicated is like just buying your own dedicated computer on the cloud, and same thing with a host as well. A dedicated host is a bit bigger than dedicated instances because a host can have multiple computers. It's like think of it as like a large computer. It can have several smaller computer instances running on it. If you want like a large amount of like security, like say the government or something like that, you can have a dedicated host as well, where anything that's running on that entire machine is only going to be your stuff. So you can make sure that nothing else can ever have access to that. And there's different like types of the computers as well. Let's say you want something that's very fast for computing, something that's general purpose, something that's more optimized for storage. You can change what CPUs, what RAM, what storage system to use depending on that, and depending on what use cases you need it to be good for. So stuff like general purpose can be used for like low traffic websites, applications, maybe small databases. Compute optimized is like video encoding, like a webinar. It's probably hosted through some form on like some high compute instance. Memory optimized for like very high performance databases, like memory caches. And then storage and accelerated computing are used for very like high intensity data use cases or stuff like machine learning as well. So Amazon and Azure and AWS, Google Cloud, that last one should just say Google Cloud, all provide a similar service for elastic compute. EC2, your virtual machines, or compute engine across all three clouds. They have a wide variety of purposes. Interestingly enough, Google does not provide Mac OS support, while Amazon and Azure do. And all of them provide on-demand, reserved, and spot instances, and they have auto-scaling groups and stuff as well. Networking. So networking is a thing across all three clouds as well. And Amazon, it's called virtual private clouds. So virtual private clouds have your own private space in the AWS cloud to get dedicated to just your account. So you have your own sort of private internet that's generated just for your specific account. And it can make sure that any of your applications can only interact with each other. You can tell them, hey, I don't want them to interact with the outside internet. I don't want anyone from the outside internet to have access to my private files or private compute instances. And you can use that through a VPC. And it's kind of like a gated community in the cloud. You get to decide who gets in, you decide what they access. You can also decide if people inside your community access the outside world. So Amazon uses VPCs, Azure uses virtual nets, and Google Cloud uses virtual networks. Databases. So we talked about a lot of different things: storage, compute, networking, regions. Now we're going to talk about databases. So the first things we have are like relational databases. So relational databases, for those of you who are not familiar with the term, is essentially databases where things are stored like Google Sheets or Excel is. Google Sheets or Excel, you have like rows and you have columns. Like you have a column for every employee ID that you have a column for every like name that you store, a column and a row for everything. And that's how data is stored. It's very structured. It's very, it's good for a lot of like most use cases. And there's a bunch of different like relational database like setups that there are, like MySQL, Oracle, SQL Server, things like that. And Amazon RDS lets you host one of these relational databases, whichever one you want, on the cloud. And the key features that it has is it's multiple availability zone. So let's say you host your application in US East. If the Virginia data center goes down, a New York data center will still be serving your data. And they read replicas as well to make sure that your performance is not impacted at all. They're simple and fast to deploy, they're fast to scale, and they're cost effective while also being secure. And they also manage common tasks like backing up, patching, things like that. Next, you have stuff like DynamoDB, which are NoSQL databases. NoSQL databases are typical to Google Sheets or Excel, or like relational databases, because they let you store any amount of data and any sort of columns you want as well. Let's say you have, like, you're storing employee, like, order information on Amazon. Um, Most orders will have like a similar sort of things, like how much the order costed, whether or not the customer had Prime, um, what product they purchased, things like that. But then some customers might leave a review, and some customers might not leave a review. So you can add a column for specific customers to say, like, hey, these customers left a review. You can put the review as part of their information on their order. Some customers might make their order a gift, and some customers might not. So you can add that as an additional column for some of the entries and some not some of the other ones. If you're doing a traditional like Excel or Google Sheets or relational database type work, then you have to add that Prime or not column, the review or not column, the gift or not column for everyone, even if it's not relevant for their order. But with a NoSQL database or a non-relational database, you can do whichever columns, whichever data you want to upload, you can upload that data for that specific customer order ID or whatever you want to use. It's extremely fast. It's extremely reliable. It has sort of seamless scalability and reliability, in that no matter how much data you add or how fast you need that data to be available, it will always be available to that speed and that requirement that you have if you set it up correctly. And it's very, very widely used. It has around 1 million plus customers among some of the biggest companies in the world as well. And it covers almost like half a million requests per second, even per customer, across several 100,000 customers. And it's much lower cost than a lot of other database environments. So, like I mentioned before, SQL versus NoSQL. SQL is like the rows and columns in Google Sheets. NoSQL is key value pairs. Schemas are fixed and dynamic. Like, you can have a order or not column, a gift or not column in NoSQL, but for SQL, everything's fixed. Queries are different in both of them as well. And SQL databases scale vertically very well, and NoSQL databases scale horizontally very well. That's just scaling depending on how fast or strong your instance is versus how many instances that you have. So if you look at the bottom, SQL will be something like that table that we have, where there's a name for everyone, a title, university, and education. Every new row that you add, you have to have a name, title, university, and education. Versus NoSQL is more sort of like abstract. It's more key value pairs. You can have a name, title, university, education for me, maybe a name and a title for someone else, maybe just university and education for another person. It's just however you want to store it, you can store it. So which sort of service do you want to use? If you have a lot of like binary objects, a lot of files or like photos you want to store, you can use S3. If you want automatic scalability, this key value pairs, you can use DynamoDB. And if you want to use like compute instances or have complete control over your database, you can host it on EC2. And there's different like database tiers for all the different cloud providers. So relational database is RDS, and then Microsoft has a bunch of them, and then Cloud SQL for the cloud, DynamoDB, Cosmos, and Firestore, Elasticache, Redis, and Memory Store, and then Neptune. So graph databases is currently only on AWS. It's a very, very new feature, and Microsoft and Google Cloud are still working on that feature, so it's not out yet. Market share, like I mentioned before, AWS is a much larger market share. Not much larger. They have a very large market share, but Azure especially is catching up, and it's a very and depending on the prices, like an average instance is cheapest on Google Cloud Platform, but there's not as many features in Google Cloud Platform for some of the niche use cases that AWS and Azure have. So AWS, despite being the most expensive on an average instance, is still the highest market share. It should goes to show their software, the quality of their software. And lastly, who are some of the major clients for these cloud providers? A lot of the biggest companies that you know all use work on a cloud. AWS has customers like Airbnb, Netflix, Coca-Cola, McDonald's, even Roblox hosts a lot of things on AWS. Azure hostings on Azure has like companies like Boeing, BMW, L'Oreal, the weather, like on your phone or on the weather.com, FedEx, and the NBA. Google Cloud has customers like Spotify, PayPal, Target, Home Depot, Etsy, and 20th Century Fox. All these big companies rely on the cloud to provide their software and provide the websites and everything they use on a day-to-day basis. It's not just something behind the scenes, it's the actual websites and the software that you use is powered by the cloud. And all these clouds have also free tier access. If you want to go on and just play around with the cloud, you don't have to pay for anything. There are free tiers in which you can play around with them and use all their software as well. So Amazon, Google Cloud, Azure, and Oracle all have free cloud providers as well. With that, that's the conclusion of our presentation on the cloud. If you have any questions or comments, please feel free to tell me right now. I'll leave a minute or so for Q&A or anything like that. But if you have any questions outside of this as well, please feel free to send them to my email. I'll be glad to answer them. Does anyone have any questions they want to ask for this, like in terms of like the live presentation or anything like that? If not, then I'll give you the time back, and please be sure to attend the Kairos AI webinar that's coming up at 2 p.m. Oh, there's a question. What kind of DB would recommend to use for personal projects? That depends on the sort of products you use, but my recommendation for a personal project would be something like a SQL database, like SQLite or MySQL. It's a very easy to use, very beginner-friendly sort of database. And you can obviously learn more databases and use cases for your personal project change. Yeah. If there's no other questions, obviously please feel free to email me with any questions after the fact as well. Please keep in mind the webinar coming up for Kairos AI at 2 p.m. and I'll give you some time back. Yeah. MySQL as well. It's a similar sort of SQL database. So the next meeting is talking about college prep and what it means like to be an entrepreneur as well. What kind of jobs deal with cloud computing? So cloud computing can be a variety of jobs. It can be like you can have sales jobs. You can have tech jobs in terms of coding using the cloud. You can have coding actual software for the cloud. You can have like IT jobs in sort of maintaining infrastructure, business jobs for like making new products and selling new products for the cloud. There's a lot of different jobs that involve the cloud, and it comes across like a lot of different like fields as well. So it has jobs from business to finance to technology, even design and stuff as well. And the main sort of takeaway, I guess, from cloud computing is that it's easy to start up and it's easy to scale. It's easy to provide for the whole world. Like scalability, flexibility, and availability, I think are the main takeaways from cloud computing. Just being able to move fast, use as much and only as much as you need, and be able to provide that for everyone to access and access from anywhere in the world. I think is a big takeaway from cloud computing. Those are great questions, by the way. All right. So volunteer opportunities on this are not necessarily going to be available. If you want to look at the HS Navigator website, there's a few more volunteer opportunities for just general like work with HS Navigator. But if you want to look up volunteer opportunities for companies and see if they have like work that's being done on the cloud, that's obviously a good thing you can look into as well. All right, with that, I'll end the webinar here. And as always, feel free to ask me if any questions after the fact as well. Thank you so much.